Hello, Mr. Ray, Mr. Ryan, right?
Yeah.
Okay, so we're given an array with n integer, right? N integers. So these n integers from 1 to n inclusive. They are 3 pigeonhole and they are 4 pigeons. So one thing we know for sure is at least one pigeonhole has
have two.
2. Yes, that's
Or
the
two or more.
yeah, 2 or more. Yes, that's pigeonhole principle. Okay.
Or one of them doesn't sit.
Yeah.
Uh-huh.
Okay. So we have n. We're given an n integer array. You know, there are n, right? Each one is from 1 to n positive integers, right? And obviously some numbers duplicate, and we need to find out the one which are not in the array, the disappearing numbers. For example, like if we give them these 1, 3, 3, 4. So which number is missing from 1 to 4? Because there are 4 elements.
2.
Yes, okay. And how about another one? So how many numbers? 1, 2, 3, 4, 5. 5 numbers. So we are looking for
2 and 5.
yes. Okay. Okay. Are we clear about this problem?
Yes.
Okay. So we're given an array with
Also
n
no
integers.
numbers. Also
Sorry?
no numbers.
Very good point. So let's just assume n is bigger than 0. Okay. So we given this non-empty array. Okay. But that's a very good corner case. Okay. So we're given this array with n integers, positive integers, and all the elements should be from 1 to n inclusive. And our target is to find out the ones which are not in the array. So find out those disappearing ones, some numbers that appearing more than once.
You can just write 1 to n, and then you compare it and see
Okay.
if
Okay, so what kind of structure can we use to remember the numbers we have seen?
a notebook.
Notebook, which is hash set. Obviously, we can convert the array to the hash set, and then we go through these numbers from 1 to n and to check if this number has appeared in the hash set. Okay, coming back to the pigeonhole. Yeah, so if I said there is duplicates, okay, so if there's duplicates in the array, at least one number is missing. For example, if there are 4 numbers, if I'm saying that one of them has duplicates, so at least one is missing because there are only 4, and then there are 4 candidates, and you say there's at least one duplicate, so we can conclude that at least one is missing. Am I right? Yes. Okay, this is very important. Okay, so coming back to this hash set notebook. So yes, we can go through this array to check if the number has appeared more than once. Have we seen this number before, right? So if not, then we
Does
put it.
the array thingy have to be sorted?
Good question. No, it doesn't have to be sorted. But if it's sorted, can you figure out? Yeah, that's a very good point. If we sort this, we can find out the answer, am I right? Easily, can we?
Yeah, you just need to count
So-
up, and if there's a missing, if it doesn't keep on adding by 1 or
Okay.
it has to add by 1 or 0 if it's going
Yeah.
doing
Okay.
it. Otherwise, any other number it won't work.
We could possibly solve this using the sorted, by sorting it first. But if there are multiple numbers which are missing, then
One,
it's a bit tricky. For example, like this one. The next one is 2, right? But it's 3, so we know 2 is missing. Okay? And then 3, 4, right? And then we keep going. And if here is 4, again, then we know 5 is missing. Yes, we can possibly solve this. But the complexity by sorting is O(n) of them, right? This one, sorting. We can do this, right? But it's not very optimum. Right? Let's talk about using the hash set first. The first one is using the hash set of notebook, right? So define, let's say this function is f, we're given this array, and then we need to convert this to hash set. So sin equals set a. Converting an array to a hash set takes O(n) time and the space O(n). Obviously, notebook needs a space. Then array, this is answer equals empty list. Then we go through this array for I. Actually, we're not going through the array, we're going through the number from 1 to n, right? In range, start with 1 up to n, right? To n, not including n plus 1 to n. then if this number not in scene, if we haven't seen this before, because this scene, yeah, is converting this array to a hash set, only remembers the unique element. If we haven't seen it before, then we push it append I, right? If we want to append I to answer, this is the list. We can also use this syntax, plus equals square bracket I, right? This is the same. Then the answer is return answer. Okay? On time, on space. Okay, so one thing missing is this n. N is the length of the A, okay? Length of the A. This is very trivial, right? Because this is the first solution we can easily think of, okay? The numbers are from 1 to n, positive, right? Then we can use the value of it as an index, okay? So we can use the value of it as an index.
But doesn't the index start on 0?
Good point, then we can subtract 1, no problem. We can go through this array and then the value, right? For example, the value 3. The value 3. Then the index is the absolute value 3 minus 1, which is the 2. So then we check this number 2, 0, 1, 2, so it should be here. This is the value. We use the value as the index. Then if this value is bigger than 0, then if it's bigger than 0, then we need to make it minus. Then the second pass, then we go through this. If we don't have any elements putting here, for example, this one, then we know 3 numbers are missing, right? 2, 5, 6, am I right? Here it should be put at 2, this is 5, this put a 6, am I right? So the value, because it's in a range, so I can use it as an index, yeah? So 1, I should put it here, right? 1, I should put it here. 1, I should put it here. 3, I should put it here. 3, I should put it here. The only buckets which we don't have any numbers put it is this one, and this one. Alright? So the first pass is going through this array by using the value as an index. You know, we know where it is stored. And then we mark it the status. And the second pass is going through the number from 1 to n, and we check which bucket is empty. Alright? And these numbers are positive, so I can use the status. I can make it a negative as a status. Okay? So let me write the code. Do you understand everything?
Sort of, yes.
Very neat, right? It's neat. This solution only works because we know the numbers are within the range from 1 to n. Define fa. We have this answer. Then we go through these numbers. And for I in A, the index is ABS absolute value I minus 1. Okay? Then if the number index is bigger than 0, right? If it's bigger than 0, then we need to neglect it. If it's negative 1, it means that we have seen this before, right? So index times equal minus 1. Okay, that's the first pass. And then second pass, for I in range, start from 1 to n plus 1. If array I is bigger than 0, then it means that we haven't seen this number before, right? If we see this number, the number will become negative. If we haven't seen this number, I, then we append this number, which is I, and then return answer. Because I, this is from 1 to n plus 1, so this is I minus 1, okay? And answer to append I. Okay, so it's very tricky to get this right because of the index start from the 0. You mentioned that, right? The index start from 0, but we are looking for the numbers from 1 to n. Okay, so to sum up, we talk about 2 approaches. The first one is using a hash set. We go through this array the first time to convert it to a hash set. And on the second time, we go through this number from 1, 2, 3, up to n. Then we check if this number has appeared in a hash set. If not, then we append it to the answer. This is very trivial. We use the hash set. Almost everybody can write it, right? It's very straightforward.
Almost.
Yes. The time complexity is O(n), the space complexity is O(n) because we are using the hash set. The second approach, because we're noticing that the numbers are from 1 up to n inclusive. So the first step is to go through this array and use the value. For example, if the value is 4, ideally, number 4 should be in the 4th bucket. If no numbers are missing, then we rearrange this we rearrange these numbers, then it'll be a sorted array. It'll be 1, 2, 3 up to n, right? So we are trying to locate the number, the bucket. So we put this number, for example, the number 4, we put it in the fourth bucket. Number 5, we put it in the fifth bucket. Number 3, we put it in the third bucket. And if they're duplicates, we can just put it in the same bucket. And then the second step is going through this array to check which bucket has empty, and then we know which numbers are missing. We are making use of the fact that the numbers are all positive, right? So we can use the value and do the absolute value and get these bucket index. And if it's bigger than 0, right? This is very important. If it's bigger than 0, then we turn into negative. Because if we keep doing negative, double negative makes positive, so we're losing the status. Alright? Yeah. Look, the 3. We're changing the third number into minus. Another number 3. It's already minus. If we multiply minus, it will be positive. Now, we don't know if we have seen this number before. So this is to prevent that we have multiple even number of the same number, then we're losing the status. The sign, if it's bigger than 0, it means this index number, this bucket has not been seen before. We haven't got this number to put in the bucket. If it's minus negative, it means that we have seen this number. Okay? And then the second step is to iterate from 1 to n and check the sign. If it's bigger than 0, it means we haven't got any number to put in this bucket, so we are missing that number. Okay, the time complexity is O(n), 2O(n), 2 linear paths, because we're iterating the numbers array, right? This is iterating the numbers twice. The space complexity is O1 constant. What have you learned? What's the problem? What have you learned? That's it.
We have an array.
Yeah, we have an array
of numbers.
Of numbers, yes.
And we want to find the missing numbers from
1 to n, yeah? Okay, so what's the solution, Eric?
We use hash set.
Yeah, hash set. The first solution, hash set, okay. So it's quite easy, the first solution. The second solution, right, Eric, can you say?
We have buckets, and then every time we just pass a number, we just put it down in the bucket.
We use the value to mark the status. So the value 4, then we know it should be in the third bucket. How do we mark it down as we have seen the 4? We change the bucket value, original bucket value, put it negative. And in this way, we're not overwriting the number, right? We're not losing the number, original number on that bucket, right? And we also know the number 4 is there.
Yeah.
Okay, that's it for today. Bye-bye.
Bye.
Bye.